Executive Vice President of Science and Policy at the American Frozen Food Institute. Thank you for joining today's call and webinar. So this is the first in our sanitation controls track of AFFI's food safety webinar series. So we'll talk a little bit about what that series means, and that if you attend all the sanitation related courses, you will be able to receive, if you're an AFFI member, a certificate of completion in that series. If you want more information after this call about that program, feel free to reach out to either myself or Sanjay Gamala on the AFFI team. So today we are going to hear and explore routine cleaning and non-routine cleaning. And I am very delighted to have Dr. Lynette Johnston with us. I've recently taught a couple of courses with Lynette, and she is an outstanding instructor. You're in for a big treat because she is actually quite good and gets awesome reviews when we teach together. So a little bit about Lynette. She's an extension associate at North Carolina State University in the Department of Food, Bioprocessing, and Nutrition Sciences. She has delivered numerous food safety workshops and has consulted with over 60 food manufacturers and distributors assisting with implementation of FSMA regulations. She has also taught food safety courses in undergraduate and graduate students at NC State, and has worked as a food microbiologist for the North Carolina Department of Agriculture, and has experience as a cheese production supervisor at Leprino Foods, an AFFI member. Lynette received her Bachelor's of Science in Food Technology at Texas Tech University and her doctorate in Food Science at NC State in 2005. Before we go into today's presentation, I'd like to turn it over to Alexis Centenary, AFFI's Manager of Communications, for some housekeeping information about today's webinar. Alexis?
Thanks, Donna. We will not be answering questions until the end of the webinar. However, throughout the webinar, you may write your questions in the text box on your GoToWebinar control panel, and Donna will read them aloud during our Q&A session. Also, this webinar is being recorded, and the recording and presentation slides will be distributed to the registrants of this webinar following the webinar. Again, we are excited to have Lynette with us today. With that, I would like to turn it over to Lynette.
Thank you. Thank you for that very kind introduction, Donna. I appreciate that. And I appreciate the opportunity to present this webinar on both routine and non-routine cleaning. We'll spend some time on routine cleaning, but we're really going to dive into non-routine, or what's known as periodic cleaning. So when we think about our food supply, sanitation truly is an important factor across the entire food chain. While the impacts may vary depending on the food and the nature of how it's grown, transported, processed, packaged, and consumed, sanitation definitely plays a key role. Now, as I'm sure many of you are aware, the impact varies from a food safety issue, including, the microbiological issues when we think about Listeria, monocytogenes, or salmonella. Also, those chemical concerns, especially allergens, knowing that the #1 recall is due to undeclared allergens. And then the ever hard to control pest activity. The lack of sanitation can certainly have an impact on quality, especially when we think about spoilage of foods, and its impact on shelf life and consumer acceptability. But what I would really want to highlight here is also sanitation is also driven by regulatory requirements. That's through GMPs, right? Those conditions and practices within the food industry for processing food under sanitary conditions. Think about personnel, the state of plant and grounds, the equipment, utensils, and are they cleanable, the design of equipment and if it's cleanable, which we're really going to hit on today. But prerequisite programs, in addition, are identified through SSOPs, or Sanitation Standard Operating Procedures, to support a HACCP plan, particularly for meat, seafood, juice, and some dairy operations. And of course, most recently, as many of you I'm sure are aware, as required through FSMA, sanitation can be recognized as a preventive control for some operations. When we take a look at this next slide, So looking at this a little closer as far as the regulatory requirements goes, and kudos to the creator of this slide. As Donna knows, it's one of my favorite slides within the Food Safety Preventive Controls Alliance curriculum. I think this slide does a great job in illustrating what a food safety system looks like under the Preventive Controls for Human Food rules. So you see, while GMPs, including an effective sanitation program, are the foundation to any food safety plan, in certain facilities, think about those ready-to-eat facilities, it is likely that some components within a sanitation program will be elevated to a preventive control. Important factors include the cleanliness of RTE food contact surfaces, focusing on the post-lethality steps of production. Listeria monocytogenes, right, is the top pathogen for many operations. Equipment and infrastructure, hardware sites, ecological niches, and the Listeria's ability to form biofilms make proper cleaning and sanitizing extremely important when it comes to controlling contamination. And we also have to think about, the pathogen's ability to grow in wet and cold environments and its ability to form biofilms, which we'll be talking about, or as we go through, especially periodic cleaning, we'll be talking about again. So cleaning and sanitizing should be considered as two discrete steps. So I just want to sort of take a step back and look at a sanitation program in general and cover some terminology here. So cleaning includes the complete removal of soil and food residue from surfaces, leaving them visually clean. And it's so important for that cleaning step to take place. Otherwise, the application of the sanitizer or perhaps a disinfectant becomes ineffective. Sanitizing is the application of a sanitizer or other treatment to a clean surface to reduce the microbial load. And so, encompassing both terms, cleaning and sanitizing, I'll refer to sanitation from here on out, describing the combined cleaning and sanitation process. So, my next slide here is titled Documented Sanitation Program. So, of course, documentation is going to be key. And good planning, I work with many small manufacturers in our state in North Carolina, and half the battle is just good planning, and that documentation becomes so important. So what makes up that sanitation program includes a master sanitation schedule, identifying equipment and areas that need to be cleaned, as well as assigning frequency to cleaning. And that's one major point that we're going to come back to later in this presentation. Another important set of documents are your standard sanitation standard operating procedures, which include step-by-step procedures, what products, utensils are used, what chemical concentration of perhaps your cleaner as well as your sanitizer, your personal protective equipment, just for the safety of the employees, and then who's accountable for those responsibilities. That should all be recorded within the procedure. And then also record keeping would be included in there as well. Followed by verification procedures. So once inspection occurs, how do you actually indicate that the sanitation was indeed effective? And of course, I think what truly is the foundation to any component within a food safety system is proper and effective training. All right, so this next slide here categorizes cleaning into 4 classifications. You see here, it's all under the master sanitation schedule. It includes routine, non-routine, seasonal, and janitorial cleaning. With the focus of this presentation really will hit on routine cleaning as well as non-routine cleaning. And when processors think of sanitation, I in fact, myself, I oftentimes think of routine cleaning initiated when a plant stops production run or does a product changeover. However, there's equipment and structural areas within a facility that are not accessible during routine cleaning. Those hard to reach and other at-risk locations not normally exposed need to be scheduled for cleaning through non-routine cleaning or periodic equipment or infrastructure cleaning. And that's what we're really going to hit on in that this non-routine section of the presentation. So, and in working with small processors out there, oftentimes we'll do a workshop for them and then we'll hear back from them within a week. And the big question is, where do I begin? When we talk about, developing food safety plans or if it's a sanitation program, the big question is, you know, they're overwhelmed, and oftentimes just knowing where to begin can be the hard part. And so what we like to teach every processor that we work for, or food facility that we work with, is understand your hazards and your risk within your facility, okay? And this is all driven by the raw materials you have coming in your door, what processes you're actually using in your facility, all right? Is there, for example, is there a lethality step, okay? What about the equipment, okay? Is it a sanitary design? Is it hard to clean? And then we think about the environment, think about those ceilings, the walls, and the floors. And then finally, the final product, okay? Does it actually support the growth of the pathogen? And that, in this case, would be Listeria monocytogenes. And then those can all, you know, factor into, and these are just a few examples of brainstorming questions, perhaps for a food safety team. So, you know, I'm not going to hit on all of them, but, you know, how do we effectively keep raw and final products separate? Okay, that's going to come into play for hygienic zoning and facility flow. Okay, that's going to drive where our sanitation program really needs to prioritize certain areas for cleaning and sanitation. Another one is what cleaning methods are appropriate based on raw materials, the in-process stream, and final products. So look, knowing the characteristics of those raw materials coming in the door. Do they present a hazard? Are they low moisture, or do we have a higher water activity where, in that case, in a higher water activity, perhaps, you know, we can use wet cleaning versus in a dry environment, dry cleaning methods are going to be very important. Another one that another question to bring up, perhaps in a brainstorming session, would be how does the design of equipment impact cleaning methods? And we're going to get into that later in this presentation as well. All right, so let's start into or get into routine cleaning. Okay, this is a critical component of a robust food safety program. This would include proactive, regularly scheduled cleaning, which prevents microbial buildup in the presence of chemical and foreign material contaminants, right? So depending on your product and your process, the frequency of routine cleaning may vary from daily to weekly or maybe even slightly longer periods when we talk about these dry environments. And typically, I think this is a key point to make here, the second bullet point, the fact that this routine cleaning is typically focused on product contact surfaces or adjacent areas that require minimal disassembly. Okay, we're talking about the immediate environment. So think about risk, right? What's the proximity in relation to perhaps a zone 1 or food contact surface and the product itself? Cleaning methods for routine cleaning, right? This could be anything from wet cleaning, dry cleaning, or dry cleaning. Wet cleaning could involve, you know, manual or automated cleaning, and dry cleaning as well. We're going to get into the differences between wet cleaning and dry cleaning and look at some of those principles. Clean out of place and clean in place, particularly for wet cleaning. And keep in mind that this is all supported by your sanitation standard operating procedures. So wet cleaning, we'll start with that. So these are procedures that are water-based, so including aqueous solutions or suspensions or wet steam. So methods in this case, we're going to talk about CIP, COP, and usually involve, oftentimes anyway, involve water hoses and some type of mechanical action, including scrubbing, utilizing buckets, brushes, or wipes. So let's just dive into the 7 steps of wet cleaning here. We're going to look at each of these in its own respect here. So the first step, looking at the 7 steps here, is dry clean and sanitation prep. And really, actually the first 2 steps, dry pickup and rinse, are very important steps to remove as much soil as possible, as most chemical cleaners are not designed to remove excess soils or gross contamination. So that dry removal of production supplies, packaging, you know, that's going to be items that you're not going to want to get wet, the scrap material, and product or ingredient spills. This just makes sure you're cleaning as well as you're sanitizing that much more effective. This may involve, and will likely involve, some level of disassembly of the equipment. In this case, the items are placed in dedicated areas such as racks, carts, COP tank, or buckets, but it should prevent any type of cross-contamination to other areas. And also this would involve emptying drain baskets as well. So now we get into the pre-rinse. So in this case, temperature is going to be very important, okay? So since proteins denature and will bind to surfaces, making removal more difficult. So it's best not to let that water temperature reach 185 degrees Fahrenheit or above. Typically, what we've seen is anywhere from 130 degrees Fahrenheit to 160 degrees Fahrenheit. And I will say, when we talk about these factors, these variables, such as temperature and the pressure, okay, to prevent atomization, you know, working with your chemical supplier, I think, is an ideal route to go. But in this case, so these first two steps are just preparing for that cleaning step. All right, so the next one is the actual application of the detergent and mechanical action. And as many of you probably know, this is all dependent on temperature, chemical, time, and mechanical action. So again, it's ideal to have that temperature between 130 to 160 degrees Fahrenheit. This is where following that label on the chemical is going to be very important. The chemical used will actually be dependent on the type of soil. Okay, so if we think about carbohydrates, all right, an alkali-based cleaner may be best. Or if you've got mineral deposits, okay, an acid-based chemical may work best as well. But again, working with your chemical supplier is best. The time to penetrate and break up soil is going to be important. And then any type of mechanical action, right? And this is going to be extremely important when we think about those areas where Listeria monocytogenes could potentially become a problem, like those harborage sites where they can sort of establish themselves and create that biofilm. So the mechanical action is going to be very important there. However, that mechanical action, you know, when we think about harborage sites, that scrubbing should not be so intense as to cause scratches or gouges in the surface being cleaned, as these then can become harborage niches for bacteria and begin the formation of biofilm. So many things to consider in each of these steps. All right, rinse and inspect. So rinse surfaces, remove soil suspended in the detergent. And again, we're looking at the same temperature, all right? And inspect for residual soils by sight, feel, and smell here. So avoid overspray or water spray on the floor and drains that might create aerosol. So again, you know, we've had questions where, you know, many people think that, you know, high pressure hose can be effective, especially when you're talking about dry clean or that pre-rinse step, your sanitation prep steps. And actually, that can actually atomize any type of contamination and cause greater problems than what you already are focusing on in cleaning. In this case, depending on the equipment, the use of a flashlight for inspection may be ideal, but you're just making sure that that cleaning step was actually indeed effective. And if in case of residual soils are left, you should go back and remove the residual soils through perhaps maybe applying detergent again, and then maybe having to apply some mechanical action. All right, then we get into assembly. So it's important here, think about this, that your equipment is clean already, so you don't want to recontaminate that surface, if you will. So it's very important to make sure employees actually have clean outerwear, and also sanitize or wash and sanitize their hands. So here you're going to be looking at verifying that all the chemical is removed, and then sanitize any inaccessible parts prior to assembling. The pre-op, okay, so before the operation can begin again, so it's important to inspect that assembled equipment is free of chemical or cleaning supplies. Then run equipment prior to that inspection to make sure you're not working out any loose food soils that may actually, you know, still been on the equipment that you now see after that equipment actually runs. And then perform verification procedures according to your company's SSOP. So many companies will use ATP as a verification activity. They may also quantify APC, or maybe look at potential index organisms where they're looking at an indication of pathogen presence. Or in some cases, they might actually look for the pathogen itself. And then finally, during this pre-op step, correct any deficiencies and of course then document that so that trends can be tracked. And finally, in the 7th step, we're sanitizing the surface. So verify your chemical concentration. This is going to go back to your EPA registered sanitizer and follow the label, right? In some cases, you're going to flood the sanitized processing area, so that whether it's with equipment, you're going to make sure that you hit all surfaces as best as possible, and also hit those infrastructure areas such as walls, floors, and drains. All right, so another, the category or within wet cleaning, operations can either be performed through clean-in-place methods, as we see a picture here. It's oftentimes used within the dairy industry. We've got a picture of a pasteurizer here, where that, the mechanical cleaning and sanitizing is actually performed in enclosed equipment, where no minimal disassembly is actually required. Whereas on the flip side, we've got the clean out of place or COP method. So this is a method of cleaning equipment by removing them from their operational area and taking them to a designated station for cleaning. So in food plants, a common use of COP cleaning methods involves pieces of equipment that are complex, small, or otherwise hard to clean, so that disassembly is required. They're disassembled, rinsed, and cleaned, and sanitized. This can occur in a designated sink with the worker scrubbing to clean, or as we see here in tanks specially designed for COP methods using automated controls. And I want you to take a look at that motor there with the cover on it. Okay, just kind of a precursor into what we're going to be talking about with periodic cleaning. All right, so then not only do we have wet methods, okay, that would be for operations that will allow for that aqueous-based cleaning. Think about those, high water activity products. Now we're going to get into dry cleaning. If you have an environment that shouldn't allow for any type of water-based cleaning nor sanitation. This would be in dry environments where you have a water activity usually less than 0.85. So looking at 7 steps again, and I kind of lumped them into certain categories here. So the first step, we're going to look at pre-sanitation preparation and securing and dismantling of equipment. So again, just like with wet cleaning, this is just, as best you can, the dry removal of production supplies, packaging, scrap, and product. In many cases, for routine cleaning here, this is going to involve some disassembly of the equipment, and again, empty those drain baskets where we do see for these dry environments, we're thinking about salmonella for these dry environments in most cases. All right, our cleaning methods, it really just depends on what the process is conducive for. So in this case, there are certain challenges when approaching sanitation in low water activity food plants. So what works best for one plant may not work best for another one. So cleaning methods include purging, okay, purging those lines maybe with an inert substance like salt, for example. The use of scrapers, brushes, etc. Can also be used. Vacuum cleaning with HEPA air filtration on the air discharge side could be, or is definitely a popular choice for dry cleaning operations. And then there's also options of using abrasive blasting. This is the use of dry ice or pelletized carbon dioxide, or the use of calcium carbonate, sodium bicarbonate. But they each come with their own sort of advantages and disadvantages. For example, dry ice, it's shown to be very effective and actually effective in lowering pathogen levels. But one of the disadvantages is that it can actually cause condensation in the environment, which you think back to this where it's dry cleaning, now we're actually causing condensation, which might be a problem. Calcium carbonate, sodium bicarbonate, issues there, that's actually quite loud. So that could be an issue just for the workers. And the buildup of actual dust from those methods can be a problem as well. Sanitizing and documentation, okay, so here we're looking at dry sanitizing methods. Commonly used sanitizer for dry equipment for food contact surfaces is quaternary ammonium combined with isopropyl alcohol. So that's been shown to be very effective, but the bottom line is we're using alcohol-based sanitizers here. That's very common. Another example is dry heat, as well as gaseous antimicrobials, and examples of this would be ozone or chlorine dioxide. Has been shown to be effective. There are some other type of gaseous antimicrobials out there that have even been shown to be more effective in that they can better get into those hard to reach areas or those nooks and crannies of the equipment, if you will. And then documentation or inspection, certainly going to be important here to make sure that we've removed as much of the food residue as possible, and looking at any type of verification methods that a company would choose to go through. Allergens here might be something that someone would look for, especially in these dry environments, if an allergenic ingredient is certainly present. And then that's followed by documentation. All right, so now let's go back to this chart here for classifications of cleaning, and we're really going to get into non-routine or periodic cleaning. And I just want to pause here for a second. I just want to say that there's a lot of great information out there by other associations, companies. So one being AFFI, that they definitely have some great information out there in their food safety zone, as well as Grocery Manufacturers Association and Commercial Food Sanitation. They have a lot of great information in regards to periodic equipment and infrastructure cleaning. So I just want to give a shout out to them. So if you have more questions or whatever, there's definitely some great information out there. So let's get into non-routine cleaning here. So before we get into periodic equipment cleaning as well as infrastructure cleaning, I want to talk about those unanticipated events, all right? You know, things don't always work the way we'd like them to. And I can think back to my days working in the cheese plant, where it always seemed that we'd have some sort of spill or major spill or overflow, and it usually happened Friday at about 4 o'clock, it seems like. But they definitely have those unanticipated events that I would actually classify as non-routine cleaning. And here we've got this picture here. This actually happened last week. My 13-year-old son, in his attempt to make his own breakfast and make his own egg, actually missed the pan. Instead of using a spatula, he flipped the egg and it landed right on the stove. Now, thankfully, you know, electric stove tops have a good sanitary design. It was easy to clean, but it just reminded me that here we've got the prime example of non-routine cleaning, especially in regards to an unanticipated event. So spills, again, overflow, leaks within a facility definitely have to be prepared for in any type of food manufacturing situation. All right, so let's get into periodic equipment cleaning as well as periodic infrastructure cleaning. So most equipment is not designed to easily clean all product and non-product contact surfaces routinely. And some disassembly to clean potential niches or harborage points is going to be required. So in many cases, microbial contamination of product contact surfaces or the product itself is not going to originate from a zone 1 area, but from a harborage point in proximity to the product contact surface. So it's in these areas where pathogens, you think about those, you know, those hard to reach places within equipment, that's where Listeria monocytogenes is going to have the time, perhaps the temperature, the nutrients, and the water, okay, required for their growth and ability to form that biofilm. And it's likely that eventually this contaminant would enter the product stream. So other advantages of periodic cleaning include preventing pest issues, improving equipment reliability, and also improving your safety as far as your workers go. So we look at this deeper. The point is to take a proactive approach to address those niche areas that may not be cleaned through routine cleaning. So you think about routine cleaning. We're doing that either daily or on a weekly basis, okay? This periodic cleaning, we're talking about maybe it's equipment that we're not going to, you know, actually clean or sanitize, but on a monthly basis, okay? So equipment tear down beyond what is performed during normal routine cleaning would be factored into periodic cleaning. In this case, it's going to entail deep and very detailed cleaning. these tasks, okay, how we organize this is all organized within the master sanitation schedule, and it's scheduled at a frequency to eliminate risk. Okay, we're going to go into a little more about this and talk about how that frequency can be determined. And again, these details of how to actually disassemble the equipment and how to clean and sanitize once that equipment is disassembled, it's all captured in the SSOP. So PEC and PIC examples, so periodic equipment cleaning examples, could be conveyors, the guards on those conveyors, taps over bearing houses. We're looking at freezers. That was actually my first job when I worked for Leprino Foods, is to actually clean the freezer. And so the timing was just perfect for that periodic cleaning for me. Looking at backs of pumps, motors, valves, spray devices. So just to give you an idea of those areas that we don't target on a frequent or routine basis. Infrastructure examples would be walls, floors, ceilings, for example, HVAC ductwork. Okay, that's something I think that can be overlooked in many facilities. Lights, pallet jacks, forklifts, and so on. Right? We're going to look at this a little bit deeper and talk about how we actually assess that equipment and what drives our decisions in prioritizing certain pieces of equipment and how frequent we actually perform cleaning and sanitizing. So here we get into, so the big question is, all right, you know, we can give this information, and this is where, you know, some of these companies will come back to us in extension and say, okay, but where do I begin? You know, this sounds great, but give me a place to start. And this is how I would sort of categorize how to start. And first, looking at the factor of your equipment, as well as the infrastructure in your facility, looking at how often you're actually going to do, how do you assign, what does periodic actually mean? So assigning that frequency. And then documentation is going to be an important factor in there as well. So when you think about equipment, we're talking about the design, okay? Also talking about the proximity of that equipment. That what's the likelihood that if we have a pathogen, or for example, Listeria, monocytogenes, that set up a biofilm within that equipment, what's the likelihood that could actually get to our product and zone 1? And then let's look at the historical evidence. We're going to go deeper into each of these factors. But for frequency, we're looking at the product, the process, and equipment design. Again, it goes back to that slide at the beginning of this presentation when it's very important to look at your own facility and understand the hazards as well as the risk, and tailor your sanitation program according to your facility. Each facility is certainly unique. And then finally, documentation, right? This is just proving that we're doing what we're saying we're doing, and we're able to track those trends and make sure that our periodic cleaning program is indeed effective. So let's take a look at each one of these factors here. So equipment and infrastructure. So assess risk based on equipment sanitary design. And it's important to go to that American Meat Institute sanitary design checklist. Okay, they've got the 10 points that will help drive that assessment in prioritizing what equipment perhaps should be on within your periodic cleaning program. Assess the post-legality production equipment initially. So it's likely that if you do have a kill step in your process, okay, I think the first place to actually look for, especially when we talk about microbial contamination, will be that equipment that is after that kill step, where you have the potential for contaminants to actually contaminate the actual final product. Here's a big driver. If the equipment is too complex for routine disassembly, then that perhaps means that you need to establish a periodic cleaning procedure for that piece of equipment. If you can't really get into the areas of that equipment just because of the disassembly issues with it. Here's another one. Look for difficult areas to clean. Liquid collection areas, so sandwich parts. So you're looking for those nooks and crannies within the equipment where Listeria can set up and thrive based on the environmental conditions. Assess hard to clean infrastructure. When we think about the infrastructure, and also think about, you know, proximity. We think about overhead pipes, or maybe it's walls that you don't always get to but may lead to cross-contamination. And then I think this is an important one, especially for those facilities who already have a sampling plan, some type of perhaps environmental monitoring plan, or any other type of verification plan in place, consider that historical evidence, all right? If you know you've had problem spots with equipment, all right? We work with a company where we know certain equipment gives them problems, so that's where they target. So that type of equipment, those pieces of equipment are certainly their priority within their sanitation program and are periodically cleaned on a more frequent basis. So here's just looking at, this is actually a bakery that we work with where they have had, you know, some trouble, and I think they're dealing with it extremely effectively. So this is actually looking at pictures of their depositor, where you can see there's a lot of, you know, this is after disassembly and before their cleaning step, but you can see that there are a lot of areas where a potential pathogen could set up or could actually establish itself. So in one case, you know, looking at what's within this red circle here, where the shaft, that they've actually had an issue with that seal, okay? So they've got preventive maintenance in place, and they couple that with periodic cleaning when preventive maintenance, when they do their routine maintenance procedures. So just a couple of examples there. Looking at another bakery that we've worked with, in this case, you can see here up in the upper left corner there, you've got their mixer with the guard, okay? Over time, that shield, right, on a routine basis, yeah, the surfaces are clean, but on a periodic basis, because product can actually get in between that plexiglass and that support there, they actually do some routine cleaning and take that, disassemble that on a periodic basis. But in the picture in the lower left corner, that's actually fruitcake in a mold press. And as you can see, there's a lot of issues there with, you know, places where you can't actually effectively clean on a routine basis. And then the other one, I think this is a good one here, especially for facilities that have cracks and issues with their flooring. Those floor scrubbers can actually be a source of contamination as well. All right, so assess your equipment. That's one of the big factors. Another one when developing a periodic cleaning program is your frequency. And this, I think, is the number one question. This is a big question. How often, if we identify equipment that might be a problem, now how often do we need to completely disassemble that equipment and actually do cleaning and sanitizing? So consider your product, the process, and equipment. So the product, does the product within your facility actually support microbial growth? And when we think about Listeria monocytogenes, we're thinking about, you know, a pH of, you know, anywhere from 4.4 or greater. Think about the water activity, right? Anywhere from 0.92 or greater. That's generally speaking. So for facilities that have products or that are making products that are conducive for, in this case, Listeria growth, you know, you might consider performing that periodic cleaning on a more frequent basis. Consider the process that goes back to that kill step, hygienic zoning, thinking about those priority areas. And then, like we've talked about here, equipment design. When you're doing your equipment assessment, if you see that you've got equipment that, yes, is indeed hard, and they are hard to clean, and it takes more steps in the disassembly, and historical evidence shows that you have problem areas, that's certainly going to up the frequency on that periodic cleaning. Now, another factor in assigning that frequency is going to be performing quantitative microbial indicator or pathogen presence testing. So once you disassemble that equipment, all right, before cleaning, an actual swab, some type of testing. In some cases, I've seen where they've done APC counts, or perhaps they're actually looking at an index organism, like an indicator of, or an index organism like Listeria species, right? Seeing the counts on an indicator or the presence of an index organism. If the counts are high, or if there's the presence of an index organism, all right, then that may mean that your pre-clean, those verification activities, that would suggest that you need to increase the amount of periodic cleaning for that piece of equipment, if it's indeed out of spec. And then the third point here is the microbial indicator should not exceed the finished product. So if you've got a finished product spec, or if you have a spec for your finished product that the APC count should be, you know, 1,000, right? And you're finding that once you tear down this equipment and you're finding levels of APC much higher than your final product specifications, like 1,000, then I would say you would definitely need to increase the frequency of performing that cleaning step. All right, and then finally, as part of that periodic cleaning program, documentation is going to be key. And we talked about this a little bit, but the master sanitation schedule is going to be very important. And this really becomes important more so for non-routine cleaning than I think it does for routine cleaning. So within this master sanitation schedule, it's going to specify the equipment as well as the task. We're going to look at the frequency of periodic cleaning. It's going to assign that frequency, the amount of time the cleaning task should take. If we think about this, we're disassembling equipment that is not usually disassembled because it's so hard to tear down. So that time is going to play a big factor here. A referenced SOP, it should reference the procedures that actually are followed by the responsible employee, and then an evaluation of cleaning. So that it was indeed completed, and the verification results. When we talk about those indicator, what type of verification that's performed, looking at either APC or again, or maybe looking at a potential pathogen presence. So in the end, this demonstrates that the plan is in place and working. It tracks trends based on that verification data. It allows for adjustments and modifications. Perhaps it means remediation of the equipment itself. And it establishes the justification for resource requirement, budget, and replacement parts that may be needed. And so when you think about this, it's good to take sort of a holistic approach to who's involved with periodic cleaning. Not only should your sanitation crew be involved with this, but think about, you know, maybe your maintenance crew being as part of this as well, and coupling those preventive maintenance activities with periodic cleaning. So this slide, I just want to take a step back and look at this in its totality. This is looking at, for example, a periodic equipment cleaning assessment. So what does this look like sort of on a I hate to use the word routine, but what does it look like every time you actually do a periodic cleaning? So your PEC assessment is going to evaluate and remediate equipment that is not typically disassembled and contains potential hardware sites. That's what we're looking for. So this involves, all right, the disassembly of the equipment, either by section or piece by piece. And during this time, you really want to take care to inspect that equipment and look for those parts of that equipment in areas where you see taking of product, or you know, where soils or the food soils might actually accumulate. So that's while you're disassembling, you're inspecting, and again, that's where you're going to take your verification or perform a verification procedure by swabbing, and then after that, perform cleaning and then do additional swabbing as well, because that's going to verify that your cleaning methods were indeed effective. This is then followed by sanitizing and then reassembly, and then once that equipment is reassembled, this will then again be cleaned. The equipment will then again be cleaned and sanitized. And like I said before, this is usually, or I think best to be performed by a cross-functional team for operations, sanitation, maintenance, and quality. I think it's important also within your master sanitation schedule to maintain a roster of each equipment area, part, and accompanying inspection and swab results. And this could be coupled with photos. But by documenting those swab results, okay, that gives you, that allows you to track those trends and really assign and best assess how often you should be tearing down that equipment and doing periodic cleaning. All right, this is an example of a master sanitation schedule, and as I said before, AFFI's Food Safety Zone, which is a fantastic source of information, you know, a lot of information, different resources, not only with sanitation, but looking at validation of certain processes and so on, but a great source of information that's provided by AFFI here. And this is looking at an example that they provide here of that master sanitation schedule. So it's defining the area, whether or not it's a PIC or PEC procedure, all right? In this case, we'd see several examples of periodic equipment cleaning, followed by the specific equipment, all right? So looking at the guards or the scales or motors, all right? How long will that task actually take? the frequency. In this case, it's weekly. Oftentimes, what I've seen and what we recommend with some of the companies that we've worked with in looking at this, we usually say start, every month to 6 weeks, depending on that equipment assessment. And then you've got the person responsible, and followed by, the initials here. And what I noticed here that AFFI has assigned here is actually color coding. Yellow might represent it looked good, when they actually did their verification swab. Green might be, that the swabs actually increased as far as their APC numbers, for example, and then red might indicate, unacceptable levels here. So in that case, red would actually, looking at tracking these trends over time, that would then justify the need for increasing that, the rate of periodic cleaning. So in summary, all right, I think as you all know, and as we all know here out in the food safety world, an effective sanitation program is not only made up of routine cleaning at those daily or weekly procedures, right, but also non-routine cleaning, and that's getting into periodic cleaning. And it really is so important for each facility to know their hazards and their risks, okay, to perform their own assessment of hazards and to develop their master sanitation schedule. Those PEC assessments to evaluate equipment for potential harbor sites and remediation, I think is going to be very important. And again, I suggest this be performed by a cross-functional team. And to all of this, right, effective training is always going to be essential. All right, I thank you for your attention. Any questions out there?
Yes, we do. Thank you, Lynette. That was excellent, as I knew you would be. So we're going to open up for questions. We had a couple actually during your presentation come through. So being that I am almost blind, I'm going to have Sarah read some of those.
Yeah, so our first question is, on a scale of 1 to 10, 10 being the highest, how important is water temperature when washing down frozen herbs? And by that we mean cleaning residual frozen herbs on a conveyor belt, floor, etc.
Would temperature be a factor?
Yeah, I mean, I think in any type of a detergent, again, it all goes back to the label, reading that label and understanding the type of soil you have. It all goes back to reading that label and understanding what is required for that particular cleaning agent. So yes, anywhere between, 130 to 160, I think is ideal. And, it also depends on what step of that sanitation, or looking at the entire cleaning step, those 7 steps. It also depends on what step you're at. Are you sanitizing? Are you doing a pre-rinse or the actual cleaning? But specifically for cleaning, I think it goes back to that label.
Great, thanks. I've got another one for you.
Yeah, we have a couple more coming in here, Lynette. So our next one is, how can a sanitation program be adapted to control noroviruses?
This is where your Leanne Jacobs affiliations come in handy.
Yeah, she's just 2 doors down. You want me to go get her? I mean, I'm kidding. No, I think that's a good question. And, we don't always think about norovirus in the food manufacturing environment. Usually we associate norovirus with the retail and food service environment. But I think it depends. It depends on the amount of handling that, amount of direct handling from people to the contact surfaces, zone 1 areas, the product itself. We work with a company that, they directly handle certain, confectionery products, So norovirus for them is going to be, definitely on their radar because of that people factor in their environment. So when we think about, norovirus, think people, that's where norovirus is coming from. So think about, the proper sewage control and, proper hand washing and so on. So think about that people factor when you're considering a generic sanitation program within your GMPs.
Now, don't they also have the challenge that EPA and FDA, for that matter, are not as willing to accept surrogates associated with norovirus in order to get approval for some of these new compounds?
Yeah, that's exactly right. And, quite honestly, at this point, I'm not sure exactly what they use as a surrogate, but that is definitely one of the challenges out there. Yeah.
Yeah, so there's just not a lot of, like, where it's on the label specifically for norovirus. I think many of the products that are out there now can be effective. They just can't label as such, which is a challenge for those.
That's right.
That, want to have it to be part of that program. All right, we got some more for you.
Yeah,
the next question is, how often would you recommend to do a cleaning or sanitation program validation for allergens and for non-GMO?
Quite honestly, I can't speak for non-GMO. That's sort of beyond the scope of where I'm at. Allergens, it depends. Okay, if you've got a product where the allergen is in every one of your products, okay, that's a different case. But if you have multiple allergens and you're doing multiple product changeovers during the day, then I think the validation of that equipment is going to be very important. But again, what was the question? How often should it be performed, the validation?
Yes.
Yeah, I think it depends, and this is where I think they have to go back and assess the situation in their facility, and also look at that equipment as well as their cleaning procedures are going to be very important in regards to allergen. So I kind of refrain from giving a number before knowing the complete story.
Right. So from a perspective of regulatory requirement, validation is not required for sanitation for allergens. However, it is a good thing to do. It's an advisable thing to do. And you should only have to do validation unless your actual system, or like Leanne was alluding to, you have changes in your process or changing in your ingredients where you may need to validate to see if you indeed have gone through the process of validating your sanitation, that if you've introduced a new allergen or a new, approach or flow or whatever, that you have to do it. And I think that's why, with people who have unique allergens, they try to use scheduling as part of their control, where they try to do it at the end of the day in regards to scheduling that particular product with unique pathogens, so that unique allergens, and then they can go into sanitation, because it just makes it easier from that perspective. But allergens are a challenge, and I think for those that have to manage that, I think that's obviously why we see so many recalls. Some of the recalls are obviously silly mistakes, but there are some challenges associated with allergens.
Right.
We have another one for you.
Yeah.
Yeah, another one for you. You are just like, this is the most questions we've ever had, Lynette.
I don't know if it's a good thing or a bad thing.
It is. It's good. It is. It means people really want to know more. So.
Our next question is, what do you think of sanitation chemical rotation regarding potential resistance development? How important is it?
So, based on what I understand, is that this is kind of, I think some companies are on the fence about this, but however, there has been studies that show that resistance can play a factor, especially with Listeria monocytogenes. So I know a lot of companies who will actually rotate their sanitizer. But I think it, coupled with that, you can't just rely on that, but I think it has to be coupled with doing, again, the proper routine cleaning, and as well as periodic cleaning. Understanding that equipment and where possible problem or potential harbor sites is going to be very important.
Very good. Next one.
Thanks. Our next question is about the frequency of PEC. Is it validated by Listeria swabbing?
So the frequency of potential pests that we
PEC.
periodic equipment cleaning.
Yeah.
Oh. Okay, so could you repeat the question? I'm sorry.
Yes, no problem. About the frequency of PEC, is it validated by Listeria swabbing?
So Lynette, I think this is a two-part question.
Certainly could.
Yeah, go ahead.
Okay.
Sorry.
Okay. I think, you know, what you choose or what a company chooses to validate, if you will, or validate their frequency, really depends on the nature of, you know, the hazards within their facility. So could Listeria species be used as a sort of a target organism? Absolutely. I think that it could definitely work. You know, one of the things I do like the idea of looking at APC or some type of quantitative data, so that I think that kind of you're able to track those trends over time and really see if your procedures for cleaning and especially cleaning as well as sanitizing are indeed effective within that equipment.
Okay, great, thank you. Our next question is, what is the difference between allergen validation and verification?
It's your favorite chapter to teach, Lynette.
Right, yes. Chapter 13, right?
Yeah.
Okay, it's sad that I'm yeah. Okay, so difference between verification and validation. Let's just look at those two terms. So let's start with validation. When we consider a process or some type of control method and we want to validate that, what we're really going back to is the science. Does the science actually prove that that control method actually works? Okay, do we have proof and justification that it actually works? Okay, whereas verification is going to answer that question of, okay, is our plan actually working according to what we were saying we wanted to do? So is the validated control method working in our facility? That's what verification is. So looking at, you know, an allergen swabbing, I think verification data can actually, you can accumulate that data where then you are performing a validation. The accumulation of that verification data proves that, for example, your cleaning methods are indeed working.
Very good. Last question.
Do you think that ATP is a definitive tool in the validation and verification of a sanitation program?
Oh, that's one, you know, everybody's got their own opinion on that. You know, I think it depends on what your target is. What's the question you want to answer? It is the question, are we worried about a potential pathogen or, you know, microbial contamination on that surface? Then perhaps ATP may not be the ideal choice, because remember, ATP is just looking at organic load. Okay, but I think if we want to answer the question of, all right, is our cleaning method, is our procedures, our cleaning procedures, are they actually effective? Then certainly ATP can give us an indication of our cleaning methods and whether or not they are effective. But looking at whether or not we have a specific allergen or a specific pathogen, is it truly effective for that? I would say directly no.
Right, and I would really question a validation of a sanitation program based on ATP data. It would have to be such a huge accumulation of historical information for it to be kind of supporting data that FDA,
I agree.
or even that matter, USDA would seem reasonable. It's kind of interesting that way. Well, awesome.
Yes, and I agree.
Go, yes. Sorry. Well, we are now No, it's great. We just want to thank you so much. This is great. And the question, the Q&A section was outstanding today. And thank you for being willing to answer all those questions, Lynette. Really do appreciate your time.
Sure.
And appreciate you being the person who kicks off our sanitation series. Again, if you are, as a participant, interested in, and you are an AFFI member interested in receiving the certificate of completion of the sanitation series, contact us here at AFFI and we can get you more information. But you have to attend all of the webinars in the series in order to get the certificate. So let us know if you would be interested in that. I want to thank again Lynette Johnston for being our speaker today and your time. As I mentioned, I look forward to teaching with you again, Lynette, in the future. I'm going to turn it over to Sarah, who will close us out.
Thanks, Donna. And thank you again, Lynette. And thank you to everyone for joining us today for this webinar. And as was mentioned previously, the presentation slides and recording are going to be distributed to all of you at the conclusion of this webinar. So please stay tuned for that follow-up email, and we look forward to your participation in future webinars. So thanks for joining and have a great day.
Thanks, everybody.
Thank you.